Okay, so I'm mute. Oh, no. Okay, great. Yeah, so I think we can resume now. And so before we start the hands-on exercises, we can. I think I would love to answer questions from the Zoom chat channels. Yeah, so Nusha asked, can we comment more on the cost function? How did you validate the cost function? So we have more. So we call it the execution simulator in FlexFlow, and the main idea is that because the computation time of these operators is very predictable and reliable. And also the data transfers for deep learning training are very large. So because most of the tensors are in tens, hundreds of megabytes or even gigabytes. So when you transfer data from one device to the other device, in most cases, you have to transfer a few gigabytes or hundreds of megabytes of data. So that also makes the data transfer time quite reliable and predictable. So based on these motivations, we did build the simulator. And so we have measured the accuracy of our cost model on different data sets, and we have more details in the papers. Sometimes we also use the profiler to validate our cost model, because the profiler will show the compute and communication time for different tasks. And we can use that to see if the actual compute and communication time matches the prediction of our cost model. Yeah. So so the cost model depends on your specific machines. So if your machine has different topologies, say whether you have NV links between GPU devices or not, that will make FlexFlow generate a potentially very different strategy for you. Because if you have NV link, then FlexFlow may prefer a strategy that has more communication, because the communication can be done very fast and in a low latency way, and you can also overlap the computer with communication. But on the other hand, if you don't have these NV link between, but just have shared PCIe bus, then FlexFlow will prefer strategies that minimize data transfer. Yes. I think the next question is asked by Eric. So both Jihao and Vinay showed detailed notes and instructions in your talks that looks to be part of a paper, chapter, book. Are those available? Yes. So we have right now we have published 2 papers about talking about the FlexFlow components, and they are available on our FlexFlow websites. And we also have a few projects working in progress. So some of the figures are coming from some in progress projects. And on the FlexFlow websites, we also have instructions for installing and using FlexFlow. Hope they will be helpful. And so Jiatian asked, does top of master branch of FlexFlow has model and hybrid parallelism support for convolution to the operator? So we haven't pushed these optimizations into the master branch, because we want to maintain a stable version of the master branch. So these features will be available in the upcoming FlexFlow release. So we are going to push the release button before the end of December. Okay. And yeah, I think Eric asked, you mentioned that it was possible to provide hints on or starting solution to MCMT search and then process from there with MCMT search. The FlexFlow.ai auto-tuning page says that when importing a strategy, MCMT search is skipped if this last bit is no longer true. Yeah, so we have slightly changed the semantic of this configuration flags. So I also saw Eric post at the FlexFlow Slack channel. So we are going to add this support in the after this bootcamp, because we don't want to make semantic changes to the bootcamp before the bootcamp. So we are going to after these changes, user can provide a previous strategy. So it can be a user handcrafted strategy that user believe this will be a efficient initialization point for the search, or it can be the best discovered strategy from a previous search. So if some of your search generates extremely good results, but because different search may give you different results, so sometimes this may not be reproduced. You can save this extremely good strategy and then reuse them as the starting point for some subsequent search. And so this will be available after the bootcamp. So yep, I think yeah, I think this so if user has any additional questions, so feel free to ask over the Slack over the Zoom chat channel. I think next I will give it to Wei to show how to how to import by how to run existing TensorFlow PyTorch models by just making a few lines of changes. Wei, why not you go ahead?
Okay.
Thank you.
Let me share my screen. And here we go. So let me increase the font. Okay. So first let me show the Keras sport. So we have this. Where is that? Okay. Okay. So we have this we have a Keras example, which is copied from the Keras GitHub repo. Oops. So it is a pretty easy, it's a pretty simple CNN model. And here we are running on the on TensorFlow Keras, so it's everything is import Keras. Let's see how to run. So if we see Python. Oops. Oh, okay. That is because I changed the. Yes. So this is because by default, my Keras is using the channel last format. I have to change it back to channel last. Yes. Now it runs, and we just stop it. Now we'll go back to the AWS instance. We have the same here. Okay, so we just need to change those import to FlexFlow. Yes, they will work. Oh. So another thing we need to make sure is FlexFlow using the channel first format. So we need to make sure we're using the channel first. Okay, so we can run it. Yes. Now, another thing I want to mention is the API of FlexFlow Keras is a little bit it's the same, but we add some additional stuff there, like the paddings. So in the Keras, the padding has to be valid or same, but here we actually can do something like we can set the paddings ourselves, like just set a tuple, and it will also work. Okay. So let me show the PyTorch stuff. So go to Bootcamp, Torch. So here is the PyTorch model. That's the AlexNet model. It is from the PyTorch repo. We just complete copied here. So it's the same one here. And in the last two lines, we just create AlexNet model and call this fx.torch to FlexFlow, and it will output this model to this file. So let me write. Torch. Okay. Okay, so you'll get this. Where's the file? It should be here or. Okay, it's here. It's the AlexNet FF. So basically, it's a text file. Actually, you don't need to run this script with the FlexFlow Python. You can actually run with the regular Python interpreter. So once you have this file, then what we can do is
wait. There's some comments in the chat asking you to paste the commands to run the scripts. Yeah.
Oh, actually, all the commands are. Let me show. I paste all the commands in the first line of this in the script file. So you can just copy it here. It'll be just work. Go back to the. So in order to run this PyTorch model, so we have this one. So this is using the native Python API. The other part is exactly the same as what I showed in the slide before. And here we have these two lines. First is to create this PyTorch model instance. And we call this apply function. And you give the input tensor. So we actually can take multiple input tensors. So we need to make it as a list. So the output tensors is also a list. With these two lines, then you can run the PyTorch model. Let me show. Takes some time. Okay, it runs. Oops. Okay, so I just want to mention that if you want to try the PyTorch support, you will need to use install the PyTorch nightly, not stable. Let me see how. So where's the link to that? Okay. No. Okay. So we go to PyTorch. And here, so you have to click nightly, and we don't need the CPU, or we don't need the CUDA. So basically you have to run this this command to install the PyTorch nightly. And we also have more examples. They are in this examples folder. So we have CPP is all the C++ examples, and the Python is in the Python folder. So we have Keras and native and Onyx and PyTorch. So you can try them and play with it, and let us know if you have any questions. Yeah. Okay, so I'm done with the demos, and let's go back to Jihao and see if he has some other things to announce.
Cool. Awesome. Thank you so much, Wei. And yeah, so before I start this, yeah, so Wei has presented the front-end support, so how we can easily modify, run FlexFlow using existing run existing models implemented in other frameworks. So before I jump to the second part of this exercise, let me try to answer the questions from the chat. Yeah, I think Shongyuan asked, in the demo, do we need to set some other -ll parameters? Yes. So these -ll parameters are used to configure the Legion runtime. So for example, if you want to before starting a FlexFlow runtime, you tell how many GPUs you would like to use for these executions. What are how much memory we should allocate for these executions, and also how many compute nodes. And Legion, if you are requiring multiple nodes, Legion will directly parallelizing the executions across the specified nodes. And so we have more the detailed list of these -ll parameters in if you go to the FlexFlow GitHub websites, the homepage should show you should show you the list of -ll parameters. And yeah, so some people are asking for sudo access to the servers. I think you can try if you already have sudo accesses, and if not, we can grant you access to on your AWS instances. And so because there are quite a few people registered for this exercise, and we don't have enough AWS instances for individual person. So our policy right now is that we allow around 4 users to share the same instance. So each instance will have 8 GPUs, and so this will allow you to run FlexFlow on large-scale runs. But on the other hand, so users will share these 8 GPUs. So if you cannot launch FlexFlow, it returns some out of resource errors. Say you don't have enough available GPU, or you cannot allocate enough memory on that GPU. That means someone else is using this GPU for running experiments. The next question, do we have the next one? Fred is not in the sudoers. Okay, I will fix it. I'll fix that after my demo. Okay, let me start to share my screen. Yeah, so next I will show how we can easily train, how we can parallelize I think we also have a few additional questions. Let me finish them. So yeah, so the one question asked is how to let Legion know which GPU to use. People have problems with shared. Yeah, so the I think if you are trying to allocate, if multiple people are running FlexFlow in parallel and are competing for GPU resources, you may get some Legion errors saying that some GPUs are busy and or are out of resource. And okay, and next slide. Okay, cool. Yeah. So so next part I will demonstrate use the DRM as an example to show how we can automatically optimize the parallelization. And let me try the command. Yep. So this is the similar command line we have seen before. And so we are using 4 GPUs and a similar model configurations, and have a batch size of 4K, and we just run for 20 epochs. And so by default, if you didn't so if you didn't provide any search strategy, FlexFlow will run the default data parallelism. It may take a while because we are allocating for a bunch of memory and resources. So yeah, so if you didn't provide any strategy or start the search, FlexFlow will say no strategy file provided, and will use the default data parallelism. And so because we are using some random generated data, so we are not going to improve the accuracy, but you can see that FlexFlow can reduce the mean square loss here. And so for using data parallelism, our throughput is around 75,000 samples per second. And so because we have done the search before in my previous demo, so in this time the previous command line stays the same, and the only difference is that instead of using data parallelism, we used the previously best discovered strategy. So this file was generated from our previous demo, and by just adding this strategy file, we start another FlexFlow run. Okay, and so for the first line, you will see a command line saying load parallelization strategy from file, this one. And again, we are using some random data sets. And so you can see that this time the training throughput can be 200 can be, I think, 0.2 million. So which is effectively 3 or 4 times faster than the previous. I think it's around 3 times faster than the previous data parallelism for this specific for the DRM model. Okay, so next part of my demonstration is so how do we profile? How can we see how this parallelization works? And so use that we can add 2 additional Legion command line to generate a profile. So this log.profile means this number means how many compute nodes you would like to generate a profile. Because we just have a single node, so we just provide 1. And we also provide a profile log file. So this tells the name of the. So this profile log files means so where we would like to generate these files. And this will make Legion profile the runs. Again, we just run the same. We just do the same run, but the only difference is that we let Legion generate a profile for these FlexFlow runs. Okay. Okay. And okay, so the next one is that we can generate we can use Legion profiler, which are available here at legionprofile.py. We can directly use this this Legion profiler and send the generated file. So this prof underscore 0.gz is the file generated by Legion, and so sometimes you can provide targets. So we're in which directory you'd like to generate this file. So we can say this is DRM on 4 V100 GPUs case and using the search strategy. And so this Legion profile is available in the Legion submodular of FlexFlow. And it will generate a visualization file. So then after this, we have a new folder called this DRM 400S. If you just go to that folder, we can see you can see index.html. So if you open this index.html, you will be able to see a Legion profile. But since this is on a remote machine, so we won't be able to visualize it here. So instead, so the profile is very similar to the ones I've showed before. Yep. So I think so. So this is the one generated and downloaded last night. So I just copied it to the Legion server for visualization. And as you can see that at the beginning you have some long, you have around 5 seconds to start the Legion runtime, because this is a very small run. So the training time is actually much shorter than the initialization time. And again, we can see the utilization of different. So we have 4 GPUs. You can see the utilization of GPUs, utilization of CPUs. I think so in this case, because most of the tasks are fast on GPU, and I think the CPU side we only run some profile tasks on CPU. So CPU is not heavily utilized, and this also shows some Legion runtime tasks. So this utility will shows the Legion execution tasks, because we have to do use Legion's infrastructure for doing dependency analysis, task execution, and scheduling optimizations. So Legion will and these utility processors tracks the performance. And again, so as Vinny has demonstrated, so this number of utility processor is some knobs we can play when running FlexFlow. So if you generate some Legion, so by default, Legion will just have 1 utility processor. And if you generate a profile and see 100% utilization of utility, that means you are that means you need to add more threads for utility processor, and Legion can automatically parallelize the computation of these dependency tasks on multiple utility processors. And in this case, in most cases our utility utilization is 0, and sometimes we have around. Should I make it larger? Seems like not. Oops. Let's just do the visualization. Also open the channel. Okay. Yeah. So in this case, because in most cases our utility is pretty the utilization of utility processor is low, meaning that we are not bottlenecked by Legion runtime overhead, but by more bottlenecked by the computation on GPUs and also data transfers. And yeah, so this will also show you the performance of different data transfers. And so you can see that there are some gaps between different between the channels across different GPU devices. That means we are not fully bottlenecked by communication. And so this will also show how different if we go to the execution per if you go to the execution per iteration, you can clearly see some overlaps between the communication between data computation and some data transfers, and so this optimization will be done automatically by the lesion runtime overhead by the lesion runtime. Okay, I think this is the demonstration of how we can automatically profiling, how we can use FlexFlow to automatically optimize parallelization, and also use profiling to understand how the optimized strategy perform. And we can also use this profiling to debug, and see if we can how we can further improve so basically this profiling will help us understand what are the fundamental bottlenecks for these executions. And I think for this one we are limited by the performance of GPU, because GPU are busy for doing compute, and we're also bottlenecked by communication, because the nature of the DRM model has communication, unavoidable communication. So we always have to do some communication. And in this case, we're not bottlenecked by any runtime overhead. Cool. And I think we have some additional questions. So let me stop sharing and okay. Yeah, so if you are unable to start your runs, sometimes there are several ways. So one is that you can specify just to run on a subset of GPU devices by using CUDA visible devices. And alternatively, you can also Legion also have some flag called CUDA, I think called CUDA skip device. That will allow you to skip busy devices, and so FlexFlow will automatically find what are the available GPU devices and run training on these available GPU devices. Yeah, so Fred asked, are the command lines, are the commands you are trying in here available in some documentation documents we can get access to? I tried certain things like prof arguments are available on the, yes. So all the Legion flags and profile flags are available on the Legion website. So it will show you how to remember that how to generate Legion prof. So remember that we have showed using this log profile and log prof log file to generate profile, and use this Legion profile Python script to generate a visualization of a specific profile. And so it will give you some index HTML you can directly open to interact with a specific profile.
Yeah, can you hear me?
Yes.
What I was asking for was basically whether all the commands that you've been entering there to do all this could be in one nice tidy place. So for example, you could take the transcript of the run history in your window right now and paste that into the chat or put it in the file.
Yep, sure.
To know exactly what you ran.
Yep, I can do that.
Thank you.
Okay. Let me. Yeah, so this is the command line I used for the demonstration. And so note that the DRM model was originally implemented in the C++ interface, but by replacing the so we just built the DRM example and directly generate an executable for the DRM model. But you can just replace the execution of DRM with FlexFlow Python, followed by any of your favorite deep neural network model, and the remaining command line stays unchanged. Okay, so the next question, I'm stuck on a core dump. and cannot follow. Yeah, so we can help you to debug offline, and we use 4 GPUs. This is a food set for the device. Right. So right now, FlexFlow assumes equal distribution across multiple dimensions. So in the soft dimensions, we allow parallelizing across exploring parallelization across these soft dimensions. But and in each dimension, we assume equally partitioning. In that, we just this will give us a well-balanced workload distribution because each task have the exact same amount of data to process. And so make sure that your batch size is a multiplier of the number of GPUs, so that we can evenly distribute the batch the training samples to different GPU devices. So Frank also asked, how should we run FlexFlow on multiple compute nodes? Yeah, so we can easily enable that by, so maybe I can share my screen to demo that. I think this is also a question that's asked by many other folks. So how we can run FlexFlow on multiple nodes? If you go to the FlexFlow, if you go to the makefile, so or whether you are making, assuming that I'm using makefile for an example, but if you use CMake, we have similar flags. So there's so it has several flags you can play with. First is that whether you'd like to include debug symbols. So because we are for production runs, we can just turn off the debug mode. And the next one is the max theme, which is the maximum number of dimensions in your model. And so because for analyzing these high dimensional figures and tensors, Legion will generate some dedicated code for perform more optimized analysis for specific number of dimensions. So that's why we ask users to tell us the maximum number of dimensions. But for most existing deep neural network models, 4 is enough, because for some language models, you only need 3 dimensions, and for image computer vision models, you need 4. And if you need any higher dimensional support, just change this max dimension to a larger number. And use CUDA should always be true, because we expect that most of the compute tasks should be running on GPU devices. And this use GuessNet is the flag you would like to turn on for multi-node executions. And by default, it is 0. And if you would like to use GuessNet, you can just turn it to 1 and rebuild this example. So use HDF means whether you, so by default, FlexFlow can support HDF formats. And but if you require some external dependencies if you require external dependencies to HDF library. So that means you need to install HDF library in order to use the HDF feature of FlexFlow. Okay, and so this alternative mappers means whether you'd like to use your custom mapper, but that's an advanced feature, and because FlexFlow can automatically generate the mapper for you, so we do not recommend people to use their own mapper, but we hope the user will use our provided mapper that will map the computation using our discovered strategy. And so once you have made the changes, you can just use make to rebuild. So for building, I think it may also require, for this rebuild, it may require you to provide implementation of GuessNet. So the user has to build their GuessNet modular, and because we set up our instances separately, so our instances are not connected, so we cannot demonstrate this multi-node runs on our AWS servers. But once you have once you have built FlexFlow by turning on the GuessNet, you can directly use MPI run dash dynamic GPU X and plus the remaining FlexFlow command lines for running multi-node version of FlexFlow. And we also have some script examples in the I think in DRM we have quite a few examples. So let me see which one is multi-node. I think the Summit is multi-node for sure, but it might be different because Summit use so this shows how to do multi-node runs, but Summit use GS, which is a Slurm-based execution. So if you just replace this GS run with MPI run, that should work for your cluster. Okay, I need to stop sharing to see the chat history. Yeah, so the next question is that I'd like to run one of the scripts in Bootcamp underscore demo with a strategy imported. Where can I find that strategy? Should I first export one and then see if I can use that one? Okay, yes, that's the expected way. So because so if you like to run any of your examples, you can you can enable the FlexFlow search by turning by setting the search budget to a non-zero number and export your strategy to external file. And then after that, you can start a new FlexFlow run that imports the best discovered strategy and parallel training using the provided strategy. And so in my demonstration, I think we have covered that a little bit in the demonstration. And okay, I think that's the. So we also have some specific questions. Okay. Yeah, I think now it's time for users to. So we have half an hour before we conclude the bootcamp today. Now it's time to. It's the office hour time. So if you have any questions, feel free to post your questions here, and we can also and one of the FlexFlow developer will help you debug your runs. Okay. Yeah, so if you have any questions, feel free to post here, and so one of us will directly talk to you and help you with your problem. Okay. And and before we conclude today's bootcamp, so if you have any, we will send out a survey after this bootcamp. So if you have any comments on how we can improve the development of FlexFlow and how we can improve future bootcamps, you can leave us comments either in the chat channel or by submitting the survey after the bootcamp. And we really appreciate the joining us for the bootcamp. Okay, since we have some additional questions, let me find the next one. Yeah, so so Daniel asked, is there an unstable development branch we can check out to try the mixed parallel kernels like convolution, or just have to wait for the December release? We have a branch, and we have a public branch to let me redo the screen sharing for it. So if you go to the oops. So if you go to the FlexFlow GitHub, and so we actually has multiple branches, and the master branch is basically the development branch, and for when we have a new release, we will let me make it larger. So when we have a new release, we will just create a dedicated release branch for that stable release. And right now, some of the optimizations users are interested in this Nico branch. So this Nico branch will include our recent support for Nico reduced synchronization, so that FlexFlow search will automatically optimize for each parameter. For each operator, should we use distributed parameter, or should we use reduce? The trade-offs are that, so for in a FlexFlow optimized strategy, you are not using in most cases, you are not using all GPUs to train for precising each operator. So that so sometimes reduce is not efficient, because if you are communicating data just between a few specific GPUs, sometimes it is much faster to use distributed parameter server. And so that's where the optimization happens. So we are trying to, based on how you parallelize the model, we are trying to figure out should Nico or distributed parameter server more efficient. And so Nico branch also includes many additional system optimizations, such as the kernel fusion, parameter computation graph optimization, and also this hybrid. So also for this high dimensional parallelization, it is also included in this Nico branch. And we are so before we so this Nico branch will be, we're currently testing the stability of this branch, and we'll push it to the master branch. And after the so this merge will happen before our December release. So you can try the figures in the Nico branch, and it will also be available in the master branch. Okay. So the next question is oh, thank you, Fred, for joining us for the bootcamp. Oh, so I also want to mention that all the materials, all the videos, and the slides we presented in the bootcamp will be will be available after this this presentation. We will put the videos on the FlexFlow websites, and all the presentations, the materials will also be available on the website. So I know that some people may not be able to join or attend the entire bootcamp because conflicts, because some conflicts, conferences or some other deadline issues. So you can so they can directly watch the videos afterwards. And yeah, I'm not sure. I think there are many very interesting questions in this chat window, and so that's why in order for few other people to watch, I try to repeat the question before answering them. But some of the questions about command line and flags that I cannot describe verbally. So I'm not sure if Zoom will allow me to include these chats as part of the video. Oh, I will figure it out. Yeah, we understand that some of the command line, because the FlexFlow has there are several knobs for that the user can play with to optimize the performance of FlexFlow and also Legion. And sometimes, in order to not waste a lot of time, we just write this command line in a script. But this script will also be available as part of the materials on the website. So the user can, if you have so later on, you can just revisit the scripts we used for. So all the scripts used for the demonstration will be available. So you can revisit. And if you have any questions, feel free to post your questions by creating a GitHub issue or post your questions. So we also have a FlexFlow Slack channel. And so when you register for the bootcamp, I think you should be able to see a link for joining FlexFlow Slack. Let me also post the link for joining Slack here. I team member.
The Slack link was already posted by somebody.
Okay, cool, awesome, yeah. Because that's awesome. So the next one is what would be the command for the torch thing? I think hopefully Wei has answered that question. Cool, thank you, Wei. And if you move to another window to try and execute something yourself, Fred asked, if you move to another window to try and execute something yourself, you just saw you lost track of the other steps. Yeah, I guess that's why. Yeah, I guess that's why we have decided to record these videos and so that users can go back and forth to see how to play with FlexFlow.
Hey, Fred, this is Pat. I have a quick question for you. Instead of typing it, I'll just ask it. But I was wondering if something like a Jupyter notebook or something would be perfect for what you're looking for.
That would be fantastic. Yeah,
okay.
Exactly.
Yep, got it. Thanks.
Sure.
Yeah, cool. Yeah, that's a great suggestion. We'll take that into consideration for the next demonstration or bootcamp. Does the strategy search takes? Yeah, so Daniel asked, does the strategy search take into consideration which GPUs are linked? Yes, so that is generated by the that is described by the FlexFlow simulator. So by default, the simulator, I can show you the code probably. Okay, so it's available in the FlexFlow runtime simulator. Yeah, I think Frank knows better about where do we construct the topology graph. Frank, do you know it's in the simulator.cc or .cu?
sorry. Could you repeat? Is it the topology?
Yeah. So
You
right. So the question is, when do we specify the connection between different GPU devices? I think by default we only assume that nodes are connected, GPUs are connected to CPU by NVLink or by PCIe, right?
No, I think on GPU on the same node are assumed to be connected in NVLink, and they are specified in simulator.cu, like the first part, where like we create a bunch of device that's basically has like the bandwidth properties.
Right. I think it's called.
It's in the .cu file.
Oh, .cu. Okay. Thank you. Yeah, that's what I'm looking for. Yeah, because I know you have much better, you're better positioned to answer this question. Right. Yeah. So this is when you construct the simulator, you can describe. So when you construct simulator, you can describe the configuration of the hardware. So you don't have to describe the computation time of different tasks, because by parallelizing a task in a specific way, we will directly measure the performance of individual operators on the GPU devices. And we do require users to tell us the connectivity between different GPU devices, including the inter GPU bandwidth between different nodes. So if you have NVLink, so if each node pair has NVLink, then this should be 20. This should be, because we require bytes per microsecond. So this means 20 gigabytes per second, which is the bandwidth of NVLink. And you also tell us the connected, so how different compute nodes are connected. So I think this is the mimic number for 100 gigabits InfiniBand. So each node pair has 100 gigabits bandwidth. And so you also describe the bandwidth between GPU and DRAM. So so if you want to move data to CPU, what's the bandwidth? And by default, we assume that GPU are connected to CPU using PCIe, so that's 16 gigabytes. And so next one, you construct the topology graph. And if you have some non-uniform or very specific topology, for example, if some node pairs, if some GPUs are connected by NVLink, but other GPU pairs do not have NVLink, you can also describe that in the simulator generate construction function. Okay, and awesome. Thank you for asking, and thank you, Frank, for answering, for telling me where can I find the corresponding code. Yeah, so one last question. Will we be able to use this AWS Access after this bootcamp finishes? Unfortunately, the answer is no, because we have to turn off. But we can keep this up for maybe one additional hours. But because this AWS credits comes from Alex, so we are using his credits for supporting this bootcamp, and we are planning to turn off the AWS servers after maybe at 1 p.m. my time. So it's 1 hour after the bootcamp. So if you like to play with the FlexFlow, you have 1 extra hours to play. And yes, but unfortunately we cannot provide long-term AWS accesses. Okay, and import. So Sojin has a question about no, cannot find FlexFlow module. I think so. Sojin, you directly send it to me, but add ways. I guess he cannot see your message. Yeah, thank you, Nirmo, for posting our Slack channel. Yeah, so I guess so Frank suggested that we can have the some websites web page or something to walk through the examples with specific command line, and so it's more efficient than watching the video or looking at the PowerPoint and paste the command line from from PowerPoint or video. Yeah, we agree, and we are thinking about having some tutorials, some web pages to talk about tutorials. So some of the examples will include how we can import existing models into FlexFlow by changing the few lines. And a second tutorial could be how we can use auto-tuning feature of FlexFlow to optimize parallelization. And a third tutorial would be some profiling optimizations. So basically, there will be a one-to-one correspondence between the tutorials and our lectures presented today. Thank you so much for the suggestion. Okay, I have a more. So Jatin asked, I have a more general question. For the model hybrid strategy, what benefits does it bring except fitting a larger modular than that one GPU cannot support it? I think so. It's that's a great question. So it has two benefits. One is to demonstrate it has a scalability. It has a scalability benefit because it will allow you to train much larger models. And the second benefit is performance, because sometimes, different operators may prefer very different dimensions for parallelization. For example, if you are using these large embedding tables, your computation is just simple embedding lookup, but it has a huge amount of parameters. So, and as a result, you will prefer this operator dimension. But for some very compute-intensive operators, so convolution might be example, or some interaction where you have a very expensive matrix multiplications, but don't have that many parameters, then data parallelism might be more efficient. So different operator may prefer different ways. And globally, because we cannot optimize different operator individually because they have dependencies and require data transfers. So that's why we have to optimize parallelization globally, and that's where we find FlexFlow might be helpful, because by globally searching for how we should parallelize individual operators and use a cost model, our simulator, to estimate the performance of different candidates, using this approach to discover more efficient strategies. I hope this answers your question. And cool. Yeah, I think cool. Yeah, I think we are coming to the end of the bootcamp. And again, thank you so much for joining the bootcamp. And I really want to thank all FlexFlow developers for making this bootcamp possible. Specifically, I want to thank Mandeep, Wei, Nirmo, and Vinay for preparing the materials for the bootcamp and helping contribute to the development of FlexFlow. And yeah, so currently FlexFlow is a very active research project, and so in addition to help accelerate the training in production, so we have been using FlexFlow to try to accelerate model training in Facebook, at the National Lab, and also in some other research and industry institutions. And in addition, we are currently using FlexFlow as a condition for conducting research. So I have presented a few examples for optimizing graph neural network training, and also optimizing, and we hope that the flexibility in FlexFlow and also the automated parallelization in FlexFlow can also help us design more efficient systems for new deep learning models. In addition to the conventional deep neural network models. And we're also using FlexFlow for other types of for thinking about what's the best way to to optimize and perform distributed training. So Frank and I, so Frank is the principal developer and the leader of the TopoOp project I presented. So we are thinking about how we can jointly optimize parallelization and network layers for accelerate distributed DNA training. So yeah, so we welcome any welcome any types of contributions. So Jia asked, is there any way to contribute to FlexFlow as a developer? Yes. So first, I want to advertise that we have bi-weekly FlexFlow developer meetings. So every other week, all FlexFlow developers will meet to discuss the ongoing issues and the plan for FlexFlow. So we strongly encourage users to join the FlexFlow bi-weekly meeting. And let me post the TAM and so let me post the TAM and the Zoom link for the FlexFlow meeting. Yep. So this is the Zoom link for the FlexFlow bi-weekly meeting, and it is happening. So it is happening at. Let me print the time. It's happening at 2 to 3 p.m. Pacific time on Thursdays. Every other Thursday. Okay. So it happens 2 to 3 p.m. Pacific time every other Thursdays, and December the 17th is our next FlexFlow developer meetings. And I think that's so if anyone is interested in knowing more or contributing to FlexFlow, you can join our meetings and we can discuss potential projects. And we can discuss potential projects or features for improving FlexFlow. So this can be some more production oriented projects for implementing performance system optimizations in FlexFlow, or it can be open-ended research projects. How to use FlexFlow to conduct to use FlexFlow's features for exciting research adventures, such as using FlexFlow for training new types of models, or jointly optimizing FlexFlow with other, using FlexFlow as a foundation for some system types of research. Yeah, so we welcome any types of contribution to FlexFlow. Yeah, so as I have briefly mentioned before, we really appreciate all audience to attend the very first FlexFlow Bootcamp. And because this is the first bootcamp, so we don't have much experience on how to organize the materials, and we know that there are much for us to improve in the future. And we will also send out a survey if you have any comments for the bootcamp or for FlexFlow development. So feel free to please submit the survey. And yeah, thank you so much for attending the bootcamp. And I think we can conclude the bootcamp. Cool. I will stop this recording.